And in the third example, we just start combining things. So if we were looking at this going from left to right, I run into the 4. I have to ask myself, inside or outside? That 4 is outside. I know that's going to be vertical. Wow. The computer is not very happy. It's vertical. The 4, will that stretch or will that compress? And maybe you've started to see that everything vertical is exactly as you see it. That 4 is going to multiply y by 4. We're going to say that that's a vertical stretch. And that would tell you you're going to take all your y values and multiply them by 4. And then we have numbers inside the function. We've got a negative, which is a horizontal reflection, and the 0.5, that'll be a horizontal stretch. We can algebraically put those together because the reflection says multiply x by -1, the stretch says multiply by 2. Putting them together, we're going to multiply our x values by -2. Algebraically, we've got our original graph. Okay? Our original graph has -2, 0. It would have -1, 1, and it looks like it has 2, 2. We could take those points, -2, 0, -1, 1, and 2, 2, and find out what's going to happen to those 3 points. Well, algebraically, above here, I need to multiply my y values by 4 and my x values by -2. Again, the math isn't hard, but make sure you don't multiply the wrong numbers by the wrong numbers. -2 is my x value. It's getting multiplied by -2. It's going to become 4. 0 is my y value. It's getting multiplied by 4. It's going to stay 0. -1 times by -2, +2. 1 times by 4, 4. And finally, 2 times by -2, -4. And 2 times by 4, 8. So if we graph this on here, we have 4, 0, 2, 4, and -4, which is off of here, and 8 will be somewhere up there. And now here becomes a new challenge. We've got our 3 points. We need to draw a connection between them. But now we start to wonder, should I connect them this way or should I connect them this way? So sometimes what I do is I make a note, this was an important point because that's where my graph started. That point was right here. It'll show up eventually. Where did that point go? It went to there. So that tells me when I go to graph, I'm going to have this as a starting point. Therefore, my graph looks like this. Visually, do the words match up with what we ended up with? Does it look like the red graph first stretched away from the x-axis, flipped over the y-axis with a horizontal reflection, and then stretched horizontally? Does it make sense? Like, is that a possibility? It looks right. It looks like we have the right reflection. Because this red one is going this way. If I would reflect horizontally, it should now go that way. So it appears to be right in that sense. Again, state the domain and range. For domain, does it have a smallest x value? Yes, that smallest x value is -2. Does it have a biggest x value? No, so it continues on forever. Ooh, that's a fancy. No, it's just slow. It's just very slow. I wish that could happen to people, where you like, my mouth would be moving, but you wouldn't hear anything, and then a little bit later, that'd be weird. Okay, so -2. Oh, there we go. To infinity. And the range, the smallest y value is 0, goes up forever to infinity. For the blue one, the domain, it doesn't have a smallest x value, so we'd start at -infinity. It includes everything up to and including 4. If you came from French immersion, in English, we use round brackets. In French immersion, they used the square bracket the other way. So that's just first English-French translation. And your range, your smallest y value is 0, going up forever, would go up to infinity. And I'm going to add a part B to this one. So we were only given function notation for this one. But I hope you recognize that the original red graph was one of the graphs that we did on the sheets. But it's not just a square root graph. The square root graph starts here. Can you see that it's a square root graph moved 2 to the left? So if I wanted to write the explicit equation of the red graph, square root graph moved 2 to the left. Did I say right? I did. Yeah, it was 2 to the left. We would show up with an x plus 2 inside the function. So in other words, f of x, the original function, was square root of x plus 2. How do you translate from function notation to an explicit notation? So for the blue graph, would be y equals, there's a 4 outside the function. Outside the functions are easy. Just put a 4 outside the function. Then inside the function, function notation says whatever's inside the function gets put into the original function where the x was. My original function was the square root of x plus 2. But now, instead of writing the x, I now write negative 0.5x plus 2. And this would be the explicit equation of the blue graph. So again, practicing our function notation and practicing switching from one to the other. That's a tricky thing to work with sometimes. Okay, questions for this one are 7, 9, and 10. So write those down and circle them at the back.